And so welcome to week 2. It's Monday. I guess it's the end of Monday, but starting the second week here. All right, so today we'll take a look at conditions and loops, and this is how we kind of write programs, how we get code to execute doing things that we want it to do. All right, so first we're gonna just start talking about kind of operations and functions, operators that produce logical values, because whenever you have an if statement, inside the if statement you need to have a conditional. Okay, inside the if statement you have something that's going to either be true or false, and the code runs if it's true, and so you need something that produces a logical value. So we've got logical values, true and false. And we have operators that kind of combine these things or deal with them, right? And so your logical operators are things like or and or not and exclusive or, and these ones are vectorized. Okay, so R has these following logical operators. Okay, and what these will do is that the logical operator, if you give it something numeric, it's going to try to coerce it into something logical. So if it's 0, it's going to become false. Everything else gets evaluated to be true. Okay, and these ones are all vectorized. Okay, and so you can give it, so x can be a vector of a certain length, y can be another vector of another length, and it will go element wise. It'll do kind of the element wise operations, and it will perform recycling if needed. Okay, and the vectorized operators will produce a vector of logical values. We also have non-vectorized logical operators. So sometimes as you're reading code, you're going to see something like the double or the double and. Those are the non-vector or, the non-vector and. And they do and or operators, except they only return vectors of length 1. They only return one logical value. And if you give it a vector, if x has multiple elements in it or y has multiple elements in it, it's only going to look at the first value. It's only going to look at the first value. And so that's what we have here. Okay, so just kind of a quick comparison. Here I got x. X is true, true, false, false. Y is false, true, false, true. And if you do x or y, the or is going to be true if either one of them is true. So true or false becomes true. True or true is true. False or false becomes false. And false or true is true. Okay. And then here, if you do x and y, okay, both of them have to be true for it to evaluate to true. So true and false is false. True and true is true. False and false is false. False and true is false. Okay. Over here, I've got the non-vector or, the double or, and here I've got the double and that's just going to look only at the first element of each vector. So I've got true or false with the double or, and so that's going to evaluate to true. True and false, and that's going to evaluate to false. And that's the double or, the double and. It only looks at the first elements. All right, so here's a few questions. What happens when you give it an NA, when you give it a missing value? What will true or NA evaluate to? Any ideas? If you put in a missing value, true or missing? Okay, that will evaluate to true. Okay, what about true and missing? True and NA. Yeah, that evaluates to NA. All right, okay, so let's go ahead and just kind of peek at the answers here. Okay, so true or NA will evaluate to true because whether the missing value is true or false, this thing's going to evaluate to true. So it doesn't matter what's inside here. So we can just say that, the result's going to be true. Okay, if this is missing, if this is NA, the answer to true and NA will depend on NA. If NA is true, the answer would be true. If this is false, then the answer is going to be false. So it depends on what's inside NA. So the answer is NA. Here I've got false or NA. Again, if NA is false, then the result will be false. If NA is true, the result will be true. So it depends on what's inside NA. And so the result is going to be NA. Whereas false and NA, that's going to evaluate to false. Okay, because whether NA is true or whether NA is false, the result of false and something is going to be false. Okay, so we can R can provide the answers to these things, whereas these ones will give NA values. There's exclusive OR. The exclusive OR operator is true only if one of the values, X or Y, is true, okay? But it's going to be false if both values are true. So here I've got kind of the vectors X and Y along with some NA values, okay? So true, X true, Y false evaluates to true. X true and Y true evaluates to false. The false and false evaluates to false, and the false and true evaluate to true. And true, false, or NA evaluated with NAs will all result in NAs. We have a couple kind of generalized operators. So you have any, you also have all, and these are generalizations of or and for kind of more than two values. So here I've got a vector of 3 logical values, 3 trues, and we ask, are any of the values true? And the answer to that is true. Are all of the values true? The answer to that is true. Okay. Here I've got true, true, and false, a mix of trues and false. Are any of the values true? That is true. Are all of the values true? That's false. Okay. And here I've got false, false, false. Are any of the values true? That's false. Are all of the values true? That's also false. If we add a zero-length vector, such as logical 0 or null or something, to a vector of logical values v, the result should not be any different, right? So if I have a vector v and I have n, and I take the result of any v, and that's true or if that's false, if I add a null object or length 0 object to v, the result of any logical 0 and v should be the same. And if I do all of to v and I do all logical 0 and v, that should produce the same result. Okay, so does that kind of make sense? Like adding a logical length 0 logical vector should not affect whatever result I was getting before, right? So if the result I was getting before with v with any v or all v was something, adding a 0 length logical vector to v shouldn't alter it because I'm basically adding nothing. So with that in mind, what would any applied to a length 0 logical vector return? And what will all applied to a length 0 logical vector return? It's a bit of a it's a bit of a brain teaser. Okay. So any applied to a length 0 logical vector will return false. And let's take a look at it why. Okay. So if I do x is logical 0 length logical vector, if I do any on x, I get false. Okay. And the reason why is this. Let's say I've got a vector u and it's true, true, true. Okay. Any applied to u is going to be true. Any applied to the logical 0 mixed with a bunch of trues is still going to be true, okay? Even if this evaluates to false. Okay, here I've got true, true, false. Any applied to v is going to evaluate to true. And then if I mix in x in here, okay, which is still a length 0 logical vector, if I mix that in there, I'm still going to get true. Here, I've got w as false, false, false. Any on w is going to be false. Okay, if any applied to a length 0 logical vector evaluated to true, then I would basically have a mix between any on true and false, and that would change the result of this thing. That would change the result. Okay, so that's why we need to have any logical 0 to evaluate to false. Okay, otherwise this result would change. Does that kind of make sense? No? All right, and so similarly, if we do all applied to a length 0 logical vector, all is going to evaluate to true. All right. And the reason for that is here. If I have u is a vector of all true values. Okay. When I call all on u, I get true. Okay. If I mix x, a length 0 logical vector, into u, it shouldn't change the result. Okay. And indeed, when all x evaluates to true, all x along with u will evaluate to true. Now, if all on the logical 0 evaluated to false, then this would end up in a different result, right? Because I would have basically a false over here along with a bunch of trues, and all applied to that would evaluate to false. Okay, so that would change. Okay, all of these other things, you know, are not altered because these all evaluate to false anyway. Okay, so these are kind of this is a little bit of a trap or trick question. Not trick question, but just it requires you to think. And you know, somebody could ask you in an interview, what does all of null evaluates to? Okay, and you might be tempted to say all applied to null is going to evaluate to logical 0 or something like that, right? That kind of makes intuitive sense. But the answer is that if you do all applied to null, it's going to return true, right? So if you do all on null, you're going to get true, right? And if you do any on the null, you're going to get false, okay? For the reason that logical 0, null is basically a zero length element of null type. Okay, we have comparison operators. Okay, comparison operators produce logical values, and they are vectorized and they perform recycling. Okay, and I think you guys are familiar with these, right? You got equality, x equal y, not equal, less than, greater than, less than or equal to, greater than or equal to. This is technically a matching thing, but it's very useful. Is the element x found in y, and it will give you true or false there. So comparison operators, generally we use them for numeric types, okay? If you do use it with a string, it's going to compare using alphabetical order, okay? And so alphabetical order, according to R, goes like this. The symbols come before 0, which comes before 1, which comes before 9, and that the numbers, digits, come before letters in the alphabet, and lowercase come before capitals, okay? And these go in just alphabetical order, which I'm not sure why the letters in the alphabet are in the order that they are, but they are. And that's what we have. So here we have, so in alphabetical order, because 1 comes before 2, as far as the characters go, the character string 10 is alphabetized before the character string 2, okay? So this becomes true. Of course, if you do use it numerically, the number 10 is not less than the number 2, so that's going to be false, okay? But as far as character strings go, the character string 10 is alphabetized before the character string 2, okay? And just for reference, this is the order of the symbols, okay? So and the symbols all kind of rank are alphabetized before the character strings, but there's no real rhyme or reason to the ordering of the symbols. Like the parentheses come here, and then the square bracket, and then the slash, backslash, and the square. You know, I don't know. I don't know. I have no idea how this came about, but here you have it. Okay. You got a bunch of is functions. This list is not meant to be complete or comprehensive in any sort of sense. But these will also return logical values. So you can just check to see if something is missing, if something is null, if something is atomic, okay? So matrices would be atomic, and atomic vectors would be atomic, okay? You can check if it's a list or a matrix, an array, you know, logical type, integer type, all of these things, okay? So all of these things exist. Any questions so far before I get into conditional statements? All right, let me go ahead and give you the quiz answer, one of the quiz answers. First quiz answer for today is A as an apple. A as an apple is your first quiz answer for today. A as an apple. Okay. All right, so we've got conditional statements, and if statements pretty much power almost all of our programming, okay? And they're written if condition, and if that condition is true, it's going to execute a code block. Otherwise, it won't, all right? The condition that goes inside an if statement must be a length 1 logical vector, and it cannot be an A, okay? Length 1 logical vector that is not an A. If you give it a condition of length greater than 1, then R will take it, but only use the first element. Everything else, if you give it something that's not logical, it's going to try to coerce it to logical. Okay. If the condition is NA, you're going to get an error, missing value or true false needed. Okay. And if the condition is length 0, like a logical 0 or a null or something, you're going to get argument is of length 0. All right. So these are errors that you will probably encounter some point in your programming career, and to help you understand why you're getting this error, I think it's useful to know that missing value inside an if statement, and NA in an if statement will trigger this, and then length 0 will trigger this. Okay. If you got a bunch of expressions that you want to run in your code block associated with the condition, then use curly braces. It's just general good practice to use the curly braces always. But if there's only one expression to execute, then the curly braces are optional, okay? Versus, like Python where you use indentation. Now, so R doesn't require indentation. I think it's good practice to use the curly brace and indentation. Sometimes I see students code and they use no indentation, and it just makes me want to cry. But well, actually, I just give up trying to read their code. But yeah, R, when you write your code inside RStudio, it automatically indents when you write an if statement. If you use an if statement and you use a curly brace, it automatically indents for you. So no excuse, really. And then at that point, you're like intentionally deleting the indentation. So shame on you. But okay, so here I've got X is the vector 1, 3, and then our condition that we're going to check is 1 in X. All right, 1 in X is true. That's a logical statement. So we can say if 1 is in X, then print hello. Well, this evaluates to true, so we execute this statement and we print out hello onto the screen. Okay, here my logical operation here, or my comparison operation, which produces a logical vector, is X greater than or equal to 2. Okay, so here X is the vector 1, 3. And if I say, is it greater than 2, first I get false, then I get true. All right, if I feed that into my if statement, okay, if, and then we got the logical vector false, true, if that, whatever, that's my condition. Okay, well, the if statement is only going to look at the first element, which is false. And so it's not going to run this line of code. Okay, so it doesn't run the line of code, and then it just gives me a warning. It says there's a warning. In this if statement, the condition has a length greater than 1, and we only use the first element, okay, which was false. And so we didn't execute this line of code. All right. If I just change it, all right, so now it's less than or equal to 2. So now my logical vector is true, false. Okay. Now we've got if X less than or equal to 2, it looks at it and it sees the true. The first element is true. And so it's going to execute the lines of code inside, and it prints out hello again. But again, it says, hey, you gave me a logical vector where the vector was with a length greater than 1. Okay, so I only want to use the first element. And so it uses the true, and then it executes. Okay, but it also gives me a warning. So if you have a logical vector greater than 1, maybe what you want to do is wrap it in any or all, depending on the situation. Maybe you need to do something different. Okay, so here I can do is, are any of the values greater than 2? Are any values of X greater than 2? And that's true. And then I can say if any of the values are greater than 2, then print this out, and that's true. So it prints out the statement. All right. Here we get an error. Okay. Here x is this vector 1 through 3, 1, 2, 3. And on Friday we talked about subsetting, and we said, you know, if you ask to subset to an index that doesn't exist in X, you're going to get an NA, right? So if I say, well, what's the fifth element in X? Fifth element is not there. It's missing. So we say if NA is greater than 2, well, we don't know the answer. Is NA greater than or equal to 2? We don't know the answer. And so it can't decide whether to execute or not execute this line. And so it gives you an error. Okay, it says missing value, and I need to know whether to do this or not do this. Okay, you can't just say, you decide. You have to decide whether it's true or false. Okay, so this is a super common error. All right, and generally you go back. So when you get it, it's going to tell you the exact line of code. It's going to say error in this part of the statement. Okay, so you say, all right, well, where's this line of code? And then you say, okay, what here is missing? Okay, x subset to the fifth element is missing. And then you go back to your code and you say, well, why is this missing? Maybe you're giving it an index that's out of position or something. Here, you get another error. Okay, so here I've got x is the vector 1, 2, 3. And I'm going to ask which value in x is equal to 4. So I got which x equal 4, right? Well, none of the values in x are equal 4. So the result is integer length 0. Okay, length 0 integer vector. There's no value here. So if I try to plug this into here, right? So I got if integer 0 equal to 4, okay, it's going to give me an error. Argument is of length 0, right? And again, these are a lot of times you get an error in R and it feels a little cryptic, okay? But I can read this and I go, oh, that makes sense, okay? Argument of length 0 means there's something inside of here which is evaluating to a logical 0 or a null, okay? And that's going to be this part right here. And so you can go through and you can try to say, well, why am I getting this? We often want to nest conditionals in each other, right? So we might want to say, check to see if this is the case. If not, try this. And if not, try this, okay? And so we've got if and else if and else. So here I've got, and whenever you use else, you've got to use the curly braces, okay? And the else has to go on the same line as the closing curly brace, okay? Otherwise, R is just going to think the if statement is complete. So here I've got if x is less than 0, print negative. Otherwise, else, check if x is greater than 0. And if so, print positive. And if that's not true, okay, then we have a final else, then it's got to be 0, right? So when I do x is equal to 3 or assign 3 to x, this is going to be false. It looks at this, the else if x is greater than 0, and it says, oh yeah, that's true, positive, okay? Here I assign 0 to x. This is false, so it evaluates this. This is false, and so it's going to trigger this last statement here. It's going to say it's 0. The statement in an else if is only going to get triggered if the kind of associated original if is false. Okay, so here I got if x, I assign 3 to x, and I ask if x is greater than 0, print positive. Okay, so it evaluates this. This evaluates to true. It does this. It prints positive. Okay, and then it skips all of this. Okay, because this is only going to get executed if this thing were false. So this will never ever get executed. Else if x greater than 1. Okay, because there's no scenario where x is greater than 1 that doesn't already trigger this. Okay. So we're going to get that, okay? One thing to keep in mind is that the if statement is not vectorized, right? If requires a logical vector of length 1, and it is not vectorized. So if you have an if statement, you cannot just give it a vector of values, right? On the other hand, there is a function called ifelse, an if else is vectorized. It requires three things. Okay, you have a condition to test, and then a result if the condition is true, and a result if the condition is false. And so something simple like if x equals 5, then I want to assign yes to n, or I want otherwise assign no to n, that can get reduced to this operation here. Okay, we can say if x equals 5, then return yes, otherwise return no, and just take the result and assign it to n. Okay, so this kind of if else statement can get reduced to this. And this will be vectorized. And I've got an example at the end of class for how to vectorize an if statement using if else. Okay. Question, why does else and else if need to be on the same line as the closing curly brace of if? Okay. The reason for it is that, okay, if I have it like this, okay, then what's going to happen is here, I'm going to just say if x is greater than 2, it's going to evaluate this, okay? And then it just thinks it's done, okay? It's going to just think it's done, okay? And here it's going to just say else if, I don't know what you're talking about, okay? And let me just put in 1 here. Okay. -1 here, okay? So here it thinks it's done, and then it gets confused, okay? What is the difference between else and else if, okay? Here, the difference, there's no major difference here, other than before I execute this line of code, I want to check another conditional, okay? So it's basically, if this is false, then do this, okay? And here, if you have, if it runs like this, okay, then there's no kind of catch, right? If this is true, run this. And if this is not true, then run this. That's what we've got, okay? But sometimes you might want to have other conditionals, right? If this first thing is like, if they don't have regular whole milk, then get reduced fat milk. And if they don't have reduced fat milk, then get low fat milk. And if they don't have low fat milk, then get skim milk or something like that, okay? And so you kind of have this hierarchy rather than just say, just to kind of catch situations that you need to account for, right? The else, if you have else with no if, then this is just going to get executed as soon as this thing is false. So sometimes you don't want to just run this, right? You want to have like a secondary plan rather than, you might want to have multiple backup plans, I guess, if it's false. Okay, so if else is vectorized, and that's it. Okay, all right, let's go ahead and talk loops. I'm going through this a little bit quickly because I'm assuming you guys were exposed to this in Stats 20, okay? But we're just kind of fine-tuning or discussing some of the finer points, I guess. We've got for loops, okay? For loops, you give it some kind of vector or a list or whatever, and it's going to just iterate through the elements in that vector, okay? And it's going to evaluate whatever piece of code, your code block for every element in that vector here, okay? So here's a very simple one for x in this vector 1 through 10, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. What for each element in there, cat x squared to the screen, okay? Along with a space to kind of separate it out. So it's going to do x is 1, and it prints 1 squared, or cats 1 to the screen. Then x is 2, and it prints or cats 2 squared 4 to the screen, then 9 all the way up to 100, okay? The squared numbers up to from 1 through 10. You can give it any kind of vector. So you can give it a list. Yeah, I could have just done separator is space. This, I don't know, this was silly, okay? You can give it a list here, and a list is a type of vector. And in this case, this is L is a list, and it is a list of length 3. Okay, there's 3 elements in it. The first is a vector 1, 2, 3. The second element is the vector A through G, character vector. The third is a logical vector, true, false. And so here I've got a for loop, and I'm going to say for y, or basically for each element in L, print out the length of y. Okay, so the first thing it's going to look at basically the contents, the first thing here, which is 1, 2, 3, and it's going to print the length 3. And then it looks at the second element, which has a length of 7. Then it looks at the third element, and that has a length of 2. And that prints out to the screen like this. Okay, so you can just say for each basically element in whatever vector, in this case, the list. Here's another example. In this case, we want to know how many letters are in a character string. And so you can't use length. If I use length, I would get 1s for all of these things, right? So you can load up data sets, and one of the variables or vectors in there is state name, okay? So the first state names in alphabetical order are Alabama, Alaska, Arizona, Arkansas, California. And so here is a character vector, 5 elements, and we're going to just take each thing for the state in state names, cat the state onto the screen, along with has the number of characters, along with this, to finish the sentence, has blank letters in its name. So this will say Alabama has 7 letters in its name, Alaska has 6 letters in its name, so on and so forth. California has 10 letters in its name. Okay, and again, I have to use ncar, right? Because for each iteration, state is a character vector with just 1 element. So the first iteration, state is a character vector with 1 element, Alabama. So if I said, instead of ncar state, if I had length of state would be 1, because state is a vector, character vector, but with only Alabama in it. At the next iteration, state would be a character vector, but only Alaska is in it, okay? And every time length of state would just be 1. That's not what we want. We want the number of characters in the name. So I have n character. All right, is that all right? The explanation there. Here, let me give you the second quiz answer. Second quiz answer today is E. E as in elephant. E as in elephant. Or echo, or else. Second quiz answer. All right, when you create a loop, a lot of times you need to store the results of your code somewhere, okay? And it's almost always better to kind of create an object to store your results first, and then update the elements in there, okay? So here I've got, I create a vector, results, res here, results, and I just repeat a missing value 10 million times, 10 to the 7, okay? This is where I'm going to store the results. And here I time how long it takes, and I just have a simple for loop. I'm going to do sequence along results, okay? And that's going to create a vector 1 through 10 million. And we're going to take 1, or x, and we're going to square it. And we're going to store it into position x, right? So first iteration, x is 1. We take 1 squared, and we store it into position 1. Next time, x is 2. 2 squared, we store it in position 2. Then we do 3 squared, store it in position 3, okay? And it does this all the way to 10 million, and here it took less than 1 second, 0.64 of a second after I time it. This is a little bit slower. Sometimes you don't know how many results you're going to get, okay? And so you just kind of create an arbitrary value. You just create an object to store these things. So I just assign 0 to results. And basically this part of the code is exactly the same as right here. It's exactly the same. But what it requires is that R has to resize the results, okay? First it's length 1, then after the second iteration it's length 2, then after the third iteration it's length 3, so on and so forth. And you got to do that. And so it takes a little bit longer. It takes a little under 3 seconds. It's not a huge difference, okay? This is even with 10 million operations. But it does slow down a tiny bit, okay? Not a huge deal, okay? However, this is incredibly slow, okay? And you'll notice here I didn't even try to do 10 to the 7, okay? Or even 10 to the 6, because I did try doing 10 to the 6, and it just stalled my computer for, I don't know, like 10 minutes, and I got impatient, so I just killed it, okay? So I did 10 to the 5, and it took 15 seconds, which feels like a long time, right? Like when you go on YouTube and you click a link and it takes 15 seconds to load a clip, you would have long left that page, right? So, I don't know when we became so impatient as a society, but having to wait more than a few seconds for something feels bad or whatever. Okay, so what's going on here is I just create an empty vector here, and then I just copy the currently existing results and appended with my new value, and I store that into results. Okay, so this will grow with each iteration, right? First time I add one squared 1, and then and that becomes results. And then on the next iteration I have 1, and I add 4, and that becomes the results. Results is now 1 4, and then I take 1 4 in results, and I take on 3 squared 9, and I copy that. And basically the whole thing of having to copy something existing into another object, I guess, just takes the computer a long time to do. Okay, so it's slow, and so even though I only did 10 to the 5, it took a long time. And when I tried to do 10 to the 6, it took a really long time, and I just eventually killed it. All right, over here I've got some while loops. Okay, while loop is so a for loop will start at the beginning of a vector and end, and it'll just do however many iterations you tell it because you got this many elements. A while loop is going to run until a condition becomes false. Okay, so this is the condition, and while this thing is true, the code chunk is gonna execute. When this becomes false, it stops, right? So I start off with I equals 1. I'm gonna take some vector, length 10 here, and we're gonna say, while I is less than 10, less than or equal to 10, then take I squared and store it into results position I, okay? So I is 1, 1 squared is 1, we store it into results position 1. And then we iterate and we increment I to be 2, and I becomes 2. I plus 1 is now I is now 2. We check this, 2 is still less than 10, so we're gonna execute this, and we fill this out, okay? And so the question is, what is the value of I when the code finishes? Okay, so let's just kind of look at the last couple of iterations. So when I is 9, 9 is less than or equal to 10, we take 9 squared and we store it into results 9, and we put an 81 into position 9. And then I plus 1, I becomes 10. And then we say, all right, is 10 less than or equal to 10? That is true. 10 squared is 100. We store that into position 10 in results. And then we run this. 10 plus 1, I becomes 11. We go back here. I is 11, and we ask, is 11 less than or equal to 10? This is false, and therefore this code does not get run, and the loop stops because the while this condition I is now 11, this is false, so the loop stops. Okay, so we have up through 10 squared 100, and I takes on the value of 11. All right, here I've got another loop. This is a repeat loop. A repeat loop is kind of the flip side of a while loop. Okay, a while loop keeps running until this statement is false. Okay, a repeat loop will keep running until it triggers a break. Okay, and so in this case, the repeat keeps running, and I have the break inside this conditional. And so the repeat will keep running until this statement is true. When this statement becomes true, then it hits break. Okay, the while keeps running until this statement becomes false. The repeat keeps running until this statement becomes true. So they're just similar, they're just kind of flip sides of the coin. Okay, so here repeat will keep running. If I didn't put this in here, the repeat would run forever and your computer would never stop. Okay, and you'd have to kind of kill the process. So here, this keeps going, and again, similarly, and then finally, when this becomes true, when I is greater than 10, then we will quit. Okay, So again, it keeps going. It fills out to 100. I is going to take on the value 11. When I is 11, this statement becomes true and it hits the break. Okay. And so break is a keyword. Break is just ends the loop. So whatever the loop is running, and then if it hits break, it just stops the loop immediately, and it quits. Okay. On the other hand, next just ends the current iteration and starts the next iteration. All right. So here I got for I in 1 through 10, and it checks this condition. If I is divisible by 2, or that is I mod 2 equals 0, then break. All right. And if this doesn't get executed, then cat I to the screen. Okay. So I is going to start off with 1 mod 2. That's not true. So this isn't going to get triggered, and it's going to cat 1 to the screen. And so what's this going to output? What happens at the next iteration? I is 2. It triggers this. So what gets output is just this. Okay. With 1, this doesn't get triggered, so it outputs 1 to the screen. When I is 2, this becomes true. 2 mod 2 is 0, so it hits break. The loop stops, and that's the end. Okay. Here's the exact same code, except I replaced break with next. Otherwise, it's exactly the same. Exactly the same. The only thing is that break has been replaced with next. So what's going to happen is I is 1, it's going to cat 1 to the screen. When I is 2, this is going to become true, right? And then it triggers next. So it skips everything else. It doesn't run any of this code down here. It skips it, and it becomes I is 3. I is 3. This is not true, so it doesn't execute next. And an input, instead, it cats 3 to the screen. And so what we're going to get is you're going to get the odd numbers, 1, 3, 5, 7, 9. Okay, because the odd numbers don't, this is not true, so it runs this out here, cat. The even numbers, this is true, and it triggers next. We've got sequence length and sequence along. Okay, these will create vectors, integer vectors that start at 1 and go up to whatever number you tell it. Okay, so here L is a list of length 3. Okay, and so if I do for x and sequence along L, x is going to this part is going to be 1, 2, 3. Okay, so it's going to start off with for x is 1, x2, x3. And then here I'm going to say print I want the length of L. And so notice what I have to do. I have to use the double square bracket. I want to do the first element of L, the second element of L when x is 2, the third element of L when x is 3. Okay. Now you might wonder, like, what's the difference here? Okay. So because all 3 of these things kind of produce the same, right? If I got 1 colon length of L, L is a length 3. It's like 1 colon 3 will give me 1, 2, 3. Sequence along L gives me 1, 2, 3. And sequence length 3 also gives me 1, 2, 3. Okay. So these things all kind of produce similar results. I think if you take stats 20, they might say, like, never do 1 colon length L. Okay. I mean, for a function, you probably shouldn't. Okay. I do 1 colon length L quite a bit. Okay. It's I don't think it's that big of a deal but when I write a function, I make sure not to use it. Okay. Because in a function, your users, they might put in something silly that breaks your code. Okay. The reason for this is that if you have something that's of length 0, 1 colon length L, right? Length of L is 0. 1 colon 0 is going to produce this vector 1, 0. Okay. 1, 0, this is going to produce problems if you try to subset L to position 1 here, right? L is a length 0 list. And so if you say, well, what is L double square bracket 1? That doesn't exist. You're going to get a subscript out of bounds error. Okay. Whereas if you use sequence along or sequence length, okay, here I've got a 0 length list. If I do sequence along L, I'm going to get a 0 length integer vector, right? And if you say, all right, for x in this 0 length integer vector, nothing gets executed. There's no code that breaks here. Okay, so this thing doesn't get executed, so nothing breaks. Okay, similarly, if you do sequence length of length 0, you get a 0 length integer vector. Okay, so that neither of these will cause problems. So if you write a function, I would say it's important to use sequence along or sequence length. Okay, but just in kind of your own little, you're messing around code, probably not that big of a deal. Let me give you your last quiz answer. Last quiz answer for today is B. B as in bear or ball, baseball, B. B is the last quiz answer. Okay. So the last few slides are about vectorizing your code, or kind of trying to make your thing a little bit more efficient. Okay. And I think I saw on Campus Wire, some of you or a few students had issues with maybe your prime factorization taking a really long time. Okay. And it could be just that you've written some really inefficient code. All right. And in those cases, like, yeah, maybe you should look at it and see if everything you're doing is necessary. So one thing when you do a prime factorization, you actually don't need to check to see if your numbers are prime, right? So you start off and you say, like, can I divide by 2? And if the answer is no, like, you get a remainder. If you can't divide by 2, then just move on and go to 3. Can you divide by 3? And if you can't divide by 3, then just move on and go to 4, and you can see if you can divide by 4. Now you might say, well, 4 is not a prime number. I shouldn't try to divide by 4, but you don't have to worry about it, right? So if 2 gave you a remainder, so you couldn't divide by 2, then 4 will also give you a remainder, okay? Because, and there's no situation where you're going to get the wrong answer because you, like, there's no way, mathematically, it is impossible to have a remainder when you divided by 2, but not get a remainder when you divided by 4, okay? So you don't have to worry about accidentally thinking that 4 is a prime number or something, okay? So you can just say, try divided by 2, nope. Try to divide by 3, nope. Try to divide by 4, nope. Try to divide by 5, nope. Try to divide by 6, and keep going like that way. You don't have to check to see if every single number you're testing out is prime. Okay. So anyway, R is not great with loops. You can use loops and stuff, but it's an interpreted language, so it runs line by line, and so loops run a little bit slow. Okay. You can often improve your code performance by vectorizing your code. Okay. But this isn't always possible. It's not always worth the effort. Sometimes to try to figure out how to vectorize the code, you might take like hours figuring this out. And what, it saves you 20 seconds in runtime operation? Like, I don't know if that was the best use of your time. Maybe it feels good, okay? And certainly it helps your brain, okay? And so maybe that was the time worth invested, okay? But if it's just to save 20 seconds and that was the end of it, we got to weigh if that's a good use of time or not, okay? There's a quote, famous quote by Donald Knuth, kind of this computer science legend. He's the one that created like LaTeX and all of the text typesetting engine stuff. And he says about 90% of the time, premature optimization is the root of all evil. It's a little hyperbolic, but you know, trying to optimize something a little too early in the process can cause some headaches. Okay. So here's an example of vectorizing a function, because if is not vectorized, but if else is, right? So this is an example from your textbook. And here it's a piecewise function. Oh, sorry. Okay. I'm going a couple minutes over, but if you just want to drop out, you got all 3 quiz answers. Okay. So here is a piecewise function. And, you know, when x is less than or equal to 0, we want negative x cubed. If x is between 0 and 1, we have x squared. And if x is greater than 1, we want the square root of x. Okay. And so here is just kind of a straightforward coding. We're going to say if x is less than or equal to 0, then the value is going to be negative x cubed. Okay. Else, if x is less than or equal to 1, then the value is going to be x squared. Okay. Note that I don't actually need to check if x is greater than 0, right? So here I got 0 is greater than x less than or equal to 1. I don't actually need to check to see if x is greater than 0 because this is only going to get executed when this is false. And this is only false when x is greater than 0. So I don't actually have to have like a secondary condition in here, okay? And likewise, I don't need to even check any kind of condition for this last one because this is only going to get executed when this is false, and this is only going to be false when x is greater than 1. So I don't even need to put a condition down here, okay, for square root of x. All right, so anyway, this works here, and that's fine. However, it is not vectorized. So here I've got this vector of values going from -2 to +2, and if I plug that into f of x, it doesn't give me what I want, because what it's going to do is it's got this vector. The first value is -2. It's going to say, okay, x is this entire vector, but it looks at the first element and it says, well, is -2 less than or equal to 0? Yeah, that's true. So the value is going to be the entire vector of x, -x raised to the third power. Okay, the entire vector -x raised to the third power, and so the plot values will be basically this vector raised -x cubed, and this is what it ends up looking like. But this is not what we want. This is not a piecewise function. This is just -x cubed, okay? And it gives me this thing. Well, you got a question. Is it fine to use equals instead of the arrow operation for assignment? I mean, it's fine. Your code will run. But, you know, it's kind of like if you were from the United Kingdom and you came here and then you spell color with a U, or I don't know, you have all of these words that are spelled differently. Americans would understand what you're saying, and we would read your literature and we would know what you're saying. But, in our brain, we would be silently judging you for not using the way it's supposed to be, okay? And that's how it is in R, okay? We use the arrow. The equal sign is fine. Sometimes I use the equal sign. I also code in Python and they use equal. And so when I'm switching back and forth, I use equal sign and, whatever. But it's, yeah, it's fine. It's fine. I'm not going to take off points as far as grading goes if you use equal sign. Okay, but people might judge your code. Okay, so if you have a non-vectorized function like we have, and you want to create kind of the string of values, then here I have to create a loop, and I'm going to say for I and sequence along x, and then we subset x down to square bracket I to the ith value. We apply f to the ith value of x, and we store that in the ith value of plot values. Okay, and when we do that, then we get the piecewise function. We get -x cubed, then we get x squared, and then we get the square root of x over here. Okay, so this works. Okay, if we don't want to, have to run a loop, you can vectorize it. Okay, and we can vectorize it using ifelse. Okay, and so here I wrote this out kind of. I don't know, all spread out, but it's quite compact in one line. So first we're going to check this condition. If x is less than or equal to 0, then do -x cubed. Otherwise, check another if. Okay, we then check if else. If x is less than or equal to 1, then give me x squared. Otherwise, give me square root of x. Okay, so I've got these nested if else's, and this is equivalent to this. Okay, and this will be vectorized. Okay. Here I've got this sequence from -2 to 2. I just apply my vectorized function and plot values, and it works. Okay, I don't have to subset x down to one value at a time, and I can just give it the entire thing. I get a warning here, all right? And I've explained the warning as to why that happens on this slide, and I'll let you read the rest of the slides on your own, okay? So we will end here, and sorry for going a few minutes over, but we'll end here for today. I think I gave you all 3 quiz answers, right? So, so we'll end here, and we will see you guys on Wednesday. Have a good evening.
Hi, Professor.
Yes.
Could I ask you a quick